For this problem, we're going to find the area of this shaded region. It is inside this circle defined by r is equal to -6 cosine theta. It is outside of this cardioid in orange, defined by r is equal to 2 minus 2 cosine theta, and it's also above the x-axis. All right, so for this problem, we have the area between two curves. All right, now before we get started, let's kind of get an estimate of this. Now, the way that I will estimate this is that I know that this is a circle. The circle has a diameter of 6, and so the radius is 3. And so the area of that circle is going to be pi times r squared, 3 squared. Now, if I look at a quarter of that circle, if I go to the center of this and just kind of draw a quarter circle, this quarter circle looks to be about the same size as the shaded region that I have here. So I'm going to estimate that the area that I get is going to be roughly the same as a quarter circle. So 9 pi over 4. This is not, of course, the exact answer. It is simply a plausibility check to make sure that the answer that I get is hopefully somewhere in the vicinity of this guess. If I get an answer when I do the integration and it's way, way different than this, then I know I must have done something incorrectly. Okay, now how do we do this problem? Well, first thing we need to do is figure out where this cross occurs, where the two curves are crossing. And so to do that, I set the two values of r equal to each other. -6 cosine theta is equal to 2 minus 2 cosine theta, and then solve for cosine of theta. So let's bring the -2 cosine theta over to the other side. So I get that -4 cosine theta is equal to 2. So cosine of theta is equal to -1/2. And therefore, I've got two options for this. If I draw the picture, so I can have the picture look like this, where it is -1, 2. Here's my angle. That angle is pi over 3, which makes this angle 2 pi over 3. So that's one option. Theta is equal to 2 pi over 3. A second option is down in the third quadrant. So if I were to draw this picture, I still have -1 here. This is 2. And so this reference angle here is still pi over 3. So I get pi over 3 plus pi, which is 4 pi over 3. Okay, now do I see that in the picture? The answer is yes. So the angle 2 pi over 3 would correspond to this line here. So that's theta is equal to 2 pi over 3. Now 4 pi over 3 would correspond to this one down here. I'm not going to draw that in the picture because I don't need that angle for the integration, but 4 pi over 3 would correspond to this direction. Now, the other boundary that I care about is this way. Now, that angle going this way, that's clearly theta is equal to pi, 1/2 rotation. So this angle here is pi. So my angle of my boundaries will be from 2 pi over 3 to pi. All right, so with that, I can now set up my integral for this problem. So the area that I will have is going to be integral 1/2 the integral from 2 pi over 3 to pi of the outer edge, which is going to be the circle, -6 cosine theta squared, minus the inner curve. The graph of the function for the inner curve is 2 minus 2 cosine theta squared d theta. Okay, so that's the setup for this one. Everything else is going to be just simply doing the integral, which is a problem that could have been asked in Cal 1. The thing that's new in this class is setting up the integral. So the area is going to be 1/2, finding the endpoints. So that was the work that I did here to find the endpoint of 2 pi over 3, and then the endpoint of pi corresponds to the negative x-axis. And then the thing that I integrate, because I'm finding the area between two curves, is going to be the outer function squared minus the inner function squared. Okay, now let's just have to do the calculations. So this is equal to 1/2 integral from 2 pi over 3 to pi of 36 cosine squared theta minus 4 minus 8 cosine theta plus 4 cosine squared theta, d theta. So 1/2 integral from 2 pi over 3 to pi. All right, so minus 4, then minus a minus makes plus 8 cosine theta. Then 36 minus 4 makes plus 32 cosine squared theta, d theta. All right, now let me divide by 2 to just get rid of that fraction. 2 pi over 3 to pi of negative 2 plus 4 cosine theta plus 16 cosine squared theta, d theta. Okay, so integral from 2 pi over 3 to pi. Now, I can integrate this. I can integrate this. This one, I should do a trig identity before I integrate. So negative 2 plus 4 cosine theta plus 16 times, the trig identity is 1 plus cosine of 2 theta divided by 2, d theta. All right, integral from 2 pi over 3 to pi. All right, 16 times 1 divided by 2 is 8 minus 2 gives me a 6 up front, plus 4 cosine theta. And then 16 divided by 2 is 8 cosine of 2 theta, d theta. Okay, now I integrate. So 6 theta plus 4 sine theta. Then I have plus 4 sine of 2 theta, evaluated between pi for the upper limit and 2 pi over 3 for the lower limit. So plugging in 6 times pi plus 4 times the sine of pi plus 4 times the sine of 2 pi minus 6 times 2 pi over 3 plus 4 times the sine of 2 pi over 3 plus 4 times the sine of 4 pi over 3. Okay, so let's see. We got 6 pi plus 0 plus 0. Sine of pi and sine of 2 pi are both 0. Minus. Over here, 6 divided by 3 is 2 times 2 is 4. Okay, sine of 2 pi over 3. Sine of 2 pi over 3, that is in the second quadrant. And so I would have plus 4 times, the reference angle is pi over 3, square root of 3 over 2. Next, sine of 4 pi over 3, that is in the third quadrant. Sine is negative in the third quadrant. And then I have 4 times the same reference angle, square root of 3 over 2. All right, these cancel. So what's left will be 6 pi minus 4 pi, which is 2 pi. And so that is the area of that shaded region. And much to my pleasure, that is close to what we had guessed initially. We had guessed a quarter circle, which was 9/4 pi. Turns out it's 2 pi. So that was pretty close to our estimate we made by just kind of eyeballing what we thought the area might be.